Hello guys, this is Juan and today I'm gonna be talking about algorithms. So first of all, if you're new to this channel, please smash the subscribe button so you can learn more about coding if you're interested. And if you're just interested in winning giveaways, I'll do giveaways every Sunday. So check it out. The next giveaway we'll be doing it will be on Sunday, March 3rd. So stay tuned. I will put the description. I will put the link to the video in my description. But let's go to the purpose of this video. So I'm going to talk about algorithms today. And before starting, let's define an algorithm. And let's go with the Google definition first of all. So let's ask Google what is an algorithm. So if we ask Google, the definition Google is going to give us is that an algorithm is a process or set of rules to be followed in calculations or other problem-solving questions, especially by a computer. I created an article about what's an algorithm on my page, on my website, Morasa Power. I'll leave the link on my description too, if you want to check it out. But it's pretty much what I'm going to be talking today. And now that we have the definition of Google, let's translate that into simple terms. So for me, the way I define an algorithm is that an algorithm it's a tool that helps you find a solution fast and simple. That's it. Yeah, that's the way I see an algorithm. This is how I define it and how it's been helping me. So if you wanna take this definition, go ahead. It's pretty much the purpose of an algorithm in simple terms. But let's define an algorithm. What do we need in order to have an algorithm? So an algorithm, I came up with this acronym FEO, which if you translate that from Spanish to English, it means ugly. But FEO stands for finite, efficient, and order. It has to have an order. So let's go with finite first. So finite. In many programs, when you're doing when you're coding, you have loops, and sometimes those loops run forever. They run forever. You're trying to come up with a solution, but your loop is running forever and it never stops. So I'm bringing that up because an algorithm it has to have a finite. It doesn't have to run forever. It has to come up with an output. So an algorithm has to give you a solution. And let's say that I'm gonna give an example with a dictionary. This is not a dictionary. I don't have a dictionary now. This is a book, but it looks like a dictionary. You should read this book. It's by Arnold Schwarzenegger. It's total pretty cool. Really great book. Going back to that subject. So I'm gonna be using a dictionary. And let's keep I'm gonna be using a dictionary, but let's keep defining it an algorithm. So that way, once we're doing the example, you have an idea what we're doing. It has to be efficient. So efficient is pretty much that it has to work. It has to do the job, and it has to have an order. So order is going back to the definition of Google. It has to follow a set of rules, but those set of rules has to be clear. So that way we can apply these algorithms in different areas. And also we can translate this into a programming language, because if it doesn't have an order, it will be really hard to translate these rules, these instructions into a program. So it has to have an order. Now let's go back to our dictionary example. So let's say that you're looking for a word, and you're looking for Juan. Oh, actually, yeah. Let's say we're looking for power, because I don't think Juan is gonna be in a dictionary. So you're looking for the word power. In my opinion, I will approach this in two ways. The first way, it will be starting from the beginning and searching all the way until I get to P. But another approach I will take will be grab the dictionary, just open it in the middle, around the middle, and then see which letter I stop by. So let's say I stop by in Q, then it means that I'm really close, and then I just do a little search. Well, if we think about it, in terms of algorithms, we're doing algorithms every time in our heads, in our brains, and that's the great things about computers, about coding, about computer science, that you can translate the process of that from the human into actual code. That's why many people are scared of artificial intelligence. But let's say, well, I gave 2 examples, and actually those 2 examples, we have 2 algorithms. The first one, where we started from point A all the way to point P, it's a linear search. You're going by one by one until you get to the word you're looking for. The second one was an algorithm called binary search. A binary search is pretty much you choose a number in the middle, and then you compare with the first element if it's the same as the one you're looking for. So in this case, we're looking for power. We compare it with, let's say it's queso, or cheese in Spanish, cheese in English. It's not the same, so we move forward or back. I don't know, Q, O, P, Q. So yeah, we move back, and we keep doing this again. So let's try that again. Let's do this, but okay, let's try this again, but with numbers. So let's say we have a list of numbers from 1 to 100, and you're trying to look for the number 47. So as I said, for binary search, you will choose a number in the middle, which is 50 in this case, and you check, you compare them. Is 47 the same as 50? No, the answer is no. So that means we went a little bit high. That means we gotta choose another number in between 1 and 50 that will give to check if we're close. So if we choose a number between 1 and 50, that will give us 25. So now we checked if 25 is the same number as 47. As we know, it's not. But now we see that we went a little bit low. So we want to go high again. That means that we're going to choose a point between 25 and 50. We choose a point between 25 and 50 in the middle. It has to be in the middle. So it's 38. In this case, well, when you get a decimal, you round it. So let's say you get 37.5, you will round it to 38. But this algorithm works no matter what. So you choose a point between 25 and 50, and that will give you 38. We check, we compare 47 and 38, and they're not the same, right? So we choose a point again in 38 and 50, that will give us 44. We check again, it's not the same. And then we check again between 44 and 50. We choose a point in between, which we're adding 3 more, so it will be 47. And indeed, we reach our number. We got the number we were looking for. So what I'm going also, okay, so we got the solution. It seems like it was a lot of work, but now if we try to translate this into a computer, like if we do that, we count the number of calculations, in this case the number of comparisons. If we did linear search, it will be 1 to 47, so that's 47 comparisons. But in this case, where we're doing a binary, if we check again, we started from 1 to 100, then 1 to 50, then 25 to 50, so we did 1, 2, 3, 4, 5, 6, 7. 7 comparisons. So imagine how much time you're saving a computer. Remember, computers don't think the same way as we do. So the way you can be efficient, the way you can have an efficient algorithm, is by having the least amount of comparisons and in the fastest time as possible. That's why it means we having an algorithm that is efficient. There are some algorithms better than the others, but that's because some algorithms could be used better in certain situations. So that's a short introduction of algorithms. My next video, I will be talking about how to code a linear search. So we're gonna be talking about the first algorithm, And stay tuned. I will put it on Sunday, the same day I will do that giveaway. But I hope this videos helps you understand more about algorithms. I know I just gave 2 examples, but you get the idea. We define an algorithm. We know it has to be efficient. It has to be. It has to have an order, and it has to be. What was the other one? It has to be finite. So those are the 3 main ones that you wanna have. That you wanna take this out of this video. So yeah, thank you very much for watching, and see you next time.